Hello students, as you are observing, in this video we are going to discuss about types of sets. There are different types of sets. Near about 9 or 10 types of sets are there. So we'll discuss each type of sets and their properties. So let's start. We'll start from finite set. The first one is your finite set. What are finite sets? As name define, if we count the members, if we are able to count the members, then this type of set is known as your finite set. Clear? Members can be counted. For example, very common set of vowels. So in this type of set, we can easily count the members of set. So this is known as your finite set. If we say that B is a set of square numbers between 1 to 30. So this is also we can count. So this type of sets are known as your finite set. Opposite to finite set, we have an infinite set. We have an infinite set. As name defined, we are unable to count the members, or we can say that members are unlimited. Members are unlimited. Best example, set of natural number. As we know that lowest natural number is 1. So 1, 2, 3, 4, and this list continues up to infinity. So this is your infinite set. Again, we can also say that, we have to give the name. Whole set of whole number. It start from 0, 1, 2, 3, and list is going on up to infinity. I am not writing over there infinity. So you can express infinite sets in this manner also and this manner also. So means you can write down infinite, or you can, if you wish, you simply use 3 dots. So this is your infinite set. Then one more set is there in which we can count the members. It's a singleton set. Let me rub the board first. Okay, our next set is singleton set. As name defined, a set having one member only. This type of set is known as your only singleton set. For example, set of even prime number. As we know that set of even prime number is 2. So this is a singleton set. Then our next set is empty or null set. empty or null set. In this type of set, we have no members. In this, this is a empty or null set. In this case, remember, it is denoted by two things. There are two symbols. Either we can use open braces and close braces. This also this one is represent empty set or null set, and one more symbol is there, phi, symbol of phi. If you draw this phi, it also represents your null set. You must remember these symbols. For example, I'm going to write in descriptive form. A student of class 7, students of class 7 with 6 feet height, or wait, we can express some more, with 8 feet height. So as we know, it's not possible for us, so this is your empty set or null set. Means in this set no members are there. Someone confuses that if 0 written it means no member. No, if within braces we have 0, only 0, within braces we have only 0, so this one is not example of empty set. This one is an example of singleton set, because one member is there, that member is your 0. So hope this one is clear to you. Move to the next part. Let me rub the board. After discussing all infinite, finite, empty or singleton set, we have a term cardinal number of a set. What is the cardinal number of a set? This is a pure number which represents the number of members present in a set. Number of members present in a set is known as your cardinal number. Okay, I'm going to take that again, same set of vowels. So this is your set of vowels. This is a set, and if anyone asks to you, write down the cardinal number of this set A, so how you write? See the symbol n of set A. This we read cardinal number of set A is equals to, then we count the members and write down the number. So this likewise you have to represent cardinal number of a set. Remember, this cardinal number is only of only of finite set. Only of finite set. We are unable to find out the cardinal number of infinite sets. So under the finite set we have finite set, then we have singleton set, then we have null set. Remember, if we have any null set is there, so n of phi, n of null set is always equal to 0, because there is a no member. So you must remember these things. Move to the next type of set. Now next type of sets are, these are generally comparing between two sets. previous sets we discussed is about number of members. What we are going to discuss right now, it's about comparing of sets. So our next topic is equal set. If two or more sets having same members only, or we can say exact same members. So this type of set is known as your equal set. For example, if we say that in set A we have letter A, B, C and D, and in set B we have a letter D, C, A, B. So if we check all the members are same as in B, there is no extra member in any set. Even their cardinal number is same, members are same. So these sets are known as equal sets and represents by this A equal to B. This is your equal set. Now what about, there is another thing, it's an equivalent set. In equivalent set, it is almost same, but here is last portion is different. Two or more sets having same cardinal number having same cardinal number means number of members are same. So these type of sets are known as your equivalent set. For example, if we say in set A we have vowels A, E, I, O, U, and in set, it's a U not 4, and in set B we have some numbers 1 to 5. So if we check, cardinal number of set A and set B are same, means what, n of A equals to 5, and here also n of B equals to 5. So in this case we say that set A and set B are equivalent set. How we represent this one in set? See this portion, A is equivalent, we use double headed arrow, likewise equivalent to B. This represents the equivalent set. You must remember this one, it's a symbol of equivalent. Hope this one is clear. Move to the next type of set. Next we are going to discuss, it's also comparing type, overlapping set. In two or more sets, if they have at least one common member, remember at least, we may have more than one common members, but if at least one common member are there, they are known as your overlapping set. in two or more set. In two or more sets, then this type of set is known as your overlapping set. For example, there are two sets. Suppose we have a set P is a set of first 5 natural number, clear, and there is a set Q having first 5 square number. So here we can see that there is a two common members 1 and 4. So here we can say P and Q are overlapping sets because in this these two are common. So here we can say P and Q are overlapping. Clear? So this is a example of overlapping. Next one is your disjoint set. I'm going to rub the example of overlapping set. Disjoint set is just opposite to the overlapping set. In this there is a word at least one common changes to no, means no common member in two or more sets. So this type of set is known as your disjoint set. For example, A is a set of A, B, C, and B is a set of 1, 2, 3. So what we are observing, in these two sets there are no common member. So these are known as your disjoint set. Hope this one is clear to you. Move to the next and last topic of today's video. It is universal set. Very important set. Hope writing is visual to you because my pink ink is going to end. In case of universal set, remember a superset. Super means bigger set. Which contain all the members of given sets. All the members of given sets is known as your universal set, and this universal set is represented by this sigma or a sign U. Clear? These two are the sign of universal sets. Sometimes actually this is likewise, but with freehand we use different types of tell. So hope this one is clear to you. These two are the symbols of universal set. Let me explain the example. Suppose we have a set A, or here we can say it's a set universal set. In this sets we have number 1, all the natural numbers up to 10. Clear? This is your universal set. Universal set may be finite, may be infinite. Remember, universal set may be finite, may be infinite. That depend upon the condition. Now again we have a set A. In this we have all the odd number less than 10. And then we have a set B in which we have all square numbers less than 10. Then again we have a set C which contain all the even number less than 10. Remember these are natural number, no? Okay, less than or equal to 10. Clear? So if we see this set contains all the members of set A as well as set B as well as set C. Also it contains some more numbers, but generally these members are also the member or part of this set. So this is a reason that this one is known as your universal set, and this is also known as your superset. Clear? So hope these are clear to you. Hope you can easily understand these type of sets. You must read your book so that you can clear your concept more. In next video we'll discuss the question answers given in your book so that these types of sets are more clear to you people. That's all for today. Thank you.